Welcome back. I'm Rene. I work for Bridge Diagnostic in Boulder, Colorado. In this session, we're going to use STS-MONITOR to do rainflow counting. Rainflow counting is also known as stress cycle counting. We open the editor. We delete the previous test. Oops. We tell the system that we want to do rainflow. Go to the editor, give the rainflow a name. We can have multiple groups doing rainflow. Double click on the group name, and we are opening the page to select the parameters of the rainflow count. Rainflow counting is a bit tricky. You have to know a little bit what your signal is going to do. You have to estimate what you can expect to have a good distribution over the numbers of bins. We have for that a test signal, which is a typical number of cycles that need to be counted, and we have some features to pollute the signal. Let's make the signal nice and clean, and we have a very nice count. Let's have a look at the signal first. The signal is plus or minus 10 microe, or 10 units. Basically, monitor always runs in arbitrary units. So we have here 10 units, but if the strain gauges are used, it will be 10 microe. The signal moves between plus 10 and minus 10. So our max range should be set to 20. So the number of bins, the 20 bins, are distributed over this max range. So one bin would account for 1 microe. We do a two-dimensional rainflow, meaning that we look at the mean value of the cycle. And the mean value is basically the maximum and the minimum of the signal. The max of the signal is 10, and the minimum of the signal is minus 10. If this signal would have an offset, for instance, that it's centered around 5, you would have a max signal of 15 and a minus of 5, but your max range is still 20. If the max range is set too high, for instance like 100, then all the counts are in the low ranges and you will end up with a large amount of cells without any count information at all. Let's put that back. We include the outliers, meaning that if a cycle is encountered which is bigger than our range, we add it into a special bin, the outlier bins. And we will accumulate the data. Data accumulation means that after we save a file of a rainflow, we save the actual count, but we keep counting. We do not reset our counters. We keep counting the rainflow. That is how rainflow is specified. It is basically a continuous collection of data over a period of time. If that is a long period of time, you don't want to have the risk that there is no data at the end of the day because something happened, like the battery system depleted of your monitoring system. So we can save the files in between, but keep accumulating the data. When the test is ended, there will be a file, the end file, that has all the data for the rainflow count. You can play with these parameters to see the effects of the different settings. Let's make a mistake. Let's say that the max range is only 1 or 5. But we included the outliers. Now we have a high count of outliers in the outlier bin. If we wouldn't do that, we only have counts which fit into our range, but we don't know that the system was encountering these bigger cycles. So the cycles are counted and edited, and we see the cycles accounted for in these bins. We have a threshold here. If the threshold is 0, we count every cycle. It doesn't matter what the size of the cycle is, but we want to count it. So if we have a little noise in the system, which is a real life situation, you see that we still have the original counts here. They're difficult to see, but they're still there. I see the counts here and I see these counts, but you see that we have an enormous amount of counts in the lower bins. We can remove that by saying that we are not interested in any cycles, for instance, smaller than 1 microe. Now all these mini cycles are removed from the pattern, and we have our original count back. We also can add resonance frequencies to the signal to show that the system actually counts these cycles. Let me reduce this cycle a little bit. So we add now a lot of mini cycles, but we still have the main cycles. And if we look at the results, we see that effect presented here. We still have the main cycles, but we have a high cycle count where the resonance frequency was. Please study this page in detail, because it is quite difficult to understand exactly how rainflow responds. We will go with these settings. We have a very short save file period for the demo that's suitable. And we know that our signals are somewhere within the 550 microe range. They are centered around 0, so I can make the max and the min symmetrical. And I think 20 by 20 bins is correct. We're going to add some sensors to it. And we have specified a rainflow test. We can leave this, we can leave that. Rainflow will not result in a displayable graph on this system. It will be saved to TDMS file, but we would like to know what we are doing. So let's go back. And for this, in this case, we will add normal recording. Go into the editor, give it a name. This is my backup. And we will add 3 sensors to it. So now the test will run rainflow, but it also will do normal recording. So we know that what we are recording, we can verify that it actually counts correctly. Save it. And it is sent to the core. Now we can start. You will see now that we only have 3 sensors in the group backup. We activate the sensors. We get the data. There is no group for the rainflow. Rainflow cannot be displayed. It's a 2-dimensional plot. Let's make some countable events. I will stop for a moment to generate more data and then continue. We jumped forward. We have recorded some data, and we're going to look what the system saved. Here you see that we have a number of files, the rainflow demo data. Let's open it up. And we see here, after the metadata, we have for each sensor now a page. And that page represents our rainflow data. We can open this, insert 3-dimensional columns, and then here we have the data recorded. It shouldn't be much of a surprise what we are seeing here. Let me do that back. You see that all the cycles are counted over the mean, and we have a large cycle count because we have a vibrating system. We want to see histograms, and we have a 2-dimensional histogram. That completes my demonstration of rainflow. Thank you for your attention. And it went wrong. Okay, let's select the data. insert three-dimensional columns. And then here we have the data recorded. It shouldn't be much of a surprise what we are seeing here. Let me do that back. You see that all the cycles are counted over the mean, and we have a large cycle count because we have a vibrating system. That completes my demonstration of rainflow. Thank you for your attention.